Hello everyone, welcome back to Fundamentals of Python Bootcamp. My name is Aman Saini and I'll be your instructor throughout the course. This is lecture number 14 and today we are going to learn about how we can write binary data to files. Okay, now let's jump on to our Jupyter notebooks and let's understand what exactly is binary files and few more things that we have learned earlier in the last lecture. Okay, so there are four basic modes in which a file can be opened. uh, we can read, we can write, we can append, and few exclusive creations like read write, read append. So these kind of things we can do. Okay, in addition, Python allow you to specify two modes in which a file can be handled. Either it is binary or text. So binary mode is used for handling all kind of non-text data like images files, any executable file or any audio file. So these kind of files are basically in non-text format, and we usually save these kind of files in the form of bytes into the disk. So when a file is opened in text mode, these files are decoded from bytes to return string objects, while the files that are opened in binary mode return contents as binary objects, meaning sequence of single bytes without any decoding. So so it's just a pure form how the data has been written in the disk. Okay, so we can use open method, same method to open any file. So in this case also we can open any file in binary mode as well. So the mode is WB here if you want to open any file in binary mode. So here we are using write in binary mode to open file with binary data. Okay, so we can do like call dot write and then whatever the string that we want to store. Okay, so here is an example. We are opening any file, sample.bin, and we are opening it WB. That means the we want to open the file in write binary format, and then we are doing file.write, and then we are writing out the binary string, and then after that we are closing it. So let's create it and let's check our folder. So here we have the file sample.bin. If we try to open a notepad, we can see the data. This binary string will be written to the sample.bin file. Okay, makes sense. We are able to create binary files. Okay, so in the above example, we have already learned this thing as well, just for the revision. In the above example, we open the file in binary write mode and then wrote some bytes contents as the binary format. But alternatively, we have used open and close methods. Okay, close and open. So so open and close can be called explicitly as shown above. However, this method requires you to perform error handling yourself. Okay, so in this case, you need to mention where and when you want to close the file. That is, ensure that the file is always closed, even if there is an error during writing. So in this case, let's say you're writing some data and in between at this stage, error comes up, but your code is now out of the context. Now the file is not closed in between. So in that case, it can be an issue. Let's say you are inside a code where you are actually appending to any file and you haven't used try catch or you haven't done error handling very well. In that case, your file will be opened and the code will be exited from the interpreter. So in that case, your file will or can be corrupt in that case. So here you have to handle your exceptions on your own. So even there is an error during writing, so um use a with statement in better to regard as it is automatically close the file when the block ends. So it's smart enough with statement. So let's give it a same example. Let's say we have some bytes. Here is some bytes. and we open the file in WB. So open in WB mode, write new file, and if we want to append into any file, we can use AB, which is for append in binary mode. And then a file name is binary underscore file, then we are writing some bytes. So it automatically closes once this code gets out of the scope of the width. Okay, so here we don't need to mention file.close or these kind of things. Okay, okay, we have executed, and let's check my file.txt is being created or not. Okay, so we have my file.txt. Let's check what are the content. So we can see there is an emoji. Okay, but we have written some bytes. Exactly right. So what it is, we are writing some data which is in binary format, and it will be written into the text. So this data is actually a Unicode for a emoji, which is smile emoji, you can see here. So that's how we can write some data which is not uh, basically defined in Python, and we can define it with using binary data, so binary format actually. So we can do that. Makes sense and it looks cool. Okay, also some bytes can be in the form of byte array, which is mutable, or bytes which has immutable as shown below. So meaning if we have this list of numbers, let's say byte array 65, 66, 67, 68, and then we are converting this particular list into byte array type. So this is basically byte array object. This sum underscore byte is a byte array object. And then doing some bytes dot append, we can append some data as well. So which means this byte array object is mutable. Okay, so immutable bytes is bytes. So this is on this particular object, immutable bytes is immutable. We can't change it because it's a bytes object. Okay, so let's try to write. Let's say we have file my underscore file dot byte underscore array, and then not it's not array. So let's my file byte dot txt, and we are writing it in WB format, and we are writing immutable bytes, and then uh, we are saving it. So you can see my file byte. So the data has been written ABCD. Cool. So that's how we can write through a byte array object, and you can see 65, 67, 68, 60, and then 33. So these are basically ASCII values. So you can go and search what are ASCII. Is just very generic format of defining any character or number or special characters in these numbers. You can go out and search like what is the range of these ASCII characters. Uh, just check it on internet. You can easily understand this thing. So that's how we are able to convert 65 into A, 66 into capital B, and so on and so forth. And that's what we have seen in the file. Okay. Now the next thing is using pickle to write binary files. So some important points on binary files first. So most of the files are available in our computer systems are binary files. Some examples of binary files are images, video, audio, archive, or any executable files. So we cannot read or open the binary files in the normal text editor. Binary files are only understood by a computer or a machine, which has some predefined sets how they are defined into the memory. So how we can read it in Python. So Pickn can help us in that case. So the process of converting the structure, it can be any list or dictionary. Basically, it can be any kind of class that you're defining into a binary stream just before writing to the file. This is also called object serialization. So whenever you see and someone calling that we have this serialized object, so just think it's like it has been converted into bytes and save it into some location. So that's what we call serialization. Converting any structure into byte stream is called serialization. Okay, then how we can do this thing? So we use dump function. So we use dump method to perform pickle operation on any binary file. It returns the object representation in byte mode. The dump method belongs to pickle module. So it's just a module pickle. You can install this pickle just by writing pip install, like say pip install pickle, or maybe conda install pickle. So you can just execute this command into your terminal and you have pickle library installed into your environment. So let's import this first. So we have imported pickle module and then we can use it. So the same, it's just same thing and only one thing is added here. So file.open, we are opening the already existing file binary.dat file. This one, where it goes, maybe I have deleted it, just a minute. Binary.dat. hmm okay, I'm sorry. Okay, so we are writing it. Okay, so it should not be available before. So we are opening the file in binary dot and we are opening it in write mode. We have a list of numbers 1 2 3 4 5, but here in case we don't want just numbers to be written into the file like we did here. So we don't want that, we want the whole list to be written into the file. So in that case we can just do, we have a file open, we have our object, we can just say pickle.dump and we want to save this particular object in this file. This particular module will take care of the thing of how the original structure is looking like, what is the original data type. Then file.close, we are just closing the file and then just do execute it and we have this binary.dat file. So you can see it's just encrypted and it's in different format that we can read it, so it's machine understandable. So how we can use it, if this particular list is converted in this format, then what is it in our use? So it's not like that, we can use it. So we have another thing that we call unpickling, the reverse operation of serialization. So the reverse conversion of byte stream back to the structure like dictionary or list or tuples or something alike, we call it as unpickling. Basically it is reverse operation of pickling. This is also called deserialization. So deserialization means converting back to the original structure of any serialized object is called deserialization. So for this thing we use load method. Okay, so it's also related to pickle module, so we can use it. Let's say we have already serialized object. So this is our serialized object binary.dat. So let's try to open. So we are opening the file binary.dat in read and byte format, and then we are just doing pickle.load in this file. It automatically returns us the original format of the data, and file.close just to make sure our files are closed for whatever we have opened earlier, and we are printing the data. So now we have data as a list, so we are able to deserialize this particular object. Makes sense, it looks cool. So we are able to do a lot of things with binary files. We can actually work on the original data, how the data is stored into the into the memory. So it's very useful and it looks cool, right? So in this whole lecture we are able to write any binary string into the binary file. We are able to write emojis, we are able to write ASCII to convert it into any kind of character, and then we are able to serialize any particular structure, let's say a list, a dictionary, tuple. We are able to write it into any file. So I guess after understanding this, you're good to go and do a lot of search, whatever the new terms you have listened into this lecture into the internet. And if you guys have any question, just ping me on the forum or maybe on my email ID. I'll give you answers. Thank you so much.